Good morning, students. So in the topic of linear equation in two variables, today I am going to take up a new topic, and the topic is conditions for solvability of linear equations. Now in our linear equations we will have two cases, consistent or inconsistent. So consistent and inconsistent system of linear equations. Let me explain what is the meaning of these two words. A system of equations is said to be consistent if it has at least one solution. On the other hand, the system is said to be inconsistent if it has no solution at all. Now if you look at the word consistent, it has written as it has at least one solution. So if we are getting some solution here, then that pair will be coming in the category of consistent. And if we are not getting any solution, that will come in the category of inconsistent. Now let me take the system of pair of linear equations a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0. Now if this system has a unique solution, then we know the condition that a1 by a2 should not be equal to b1 by b2. And in this case, you can find out the value of x and y. And we have these two formula obtained from the method of cross multiplication. To find the value of x, we have the formula b1 into c2 minus b2 into c1 whole divided by a1 into b2 minus a2 into b1. And to find the value of y, we have the ready-made formula a1 into c2 minus c2 into a1 whole divided by a1 into b2 minus a2 into b1. Now this are the ready-made formula by which we can find out the value of x and y, but it is only possible when it is going to satisfy the condition of unique solution, that is a1 by a2 not equal to b1 by b2. Now if it has infinite number of solutions, then we are having the condition a1 by a2 equal to b1 by b2 equal to c1 by c2. That means all the ratios will be equal, then it is going to give me the infinite solution. Now both the cases 1 and 2, they come in the category of consistent. In consistent we can have unique solution or we can have infinite solution. In the third case, has no solution, that is known as inconsistent, and the condition was a1 by a2 equal to b1 by b2 not equal to c1 by c2. So if you look at the three cases here, we have already discussed these three cases. Out of these three cases, the first and second will come in the category of consistent, and the third will be coming in the category of inconsistent. Now let me explain this with the help of suitable examples. So let me have the first question. Check whether the given equation will have unique solution, and the equations are 2x plus 5y is equal to 17, 5x plus 3y is equal to 14. And now if you look at the coefficients, a1 is 2, b1 is 5 and c1 is minus 17, a2 is 5, b2 is 3, c2 is minus 14. And now if we go for the ratio of a1 by a2, that is 2 by 5, b1 by b2 is coming as 5 by 3. Now since they are not equal, that means a1 by a2 is not coming equal to b1 by b2, and so we can come to the conclusion that it will have unique solution. So look at the way we have done it. First we have written the coefficients, then we have checked the ratio. If the ratio is not coming to be equal, then this pair of equation will give me unique solution. Now to find the unique solution, we have the ready-made formula here, x and y, by which you can find out the value of x and y separately. So this was the case of unique solution. Now coming to the next part, check whether the given equation will have infinite solutions. And we have the equation 4x plus 6y is equal to 7, 12x plus 18y is equal to 21. And again we are going to take up the coefficients. A1 is 4, B1 is 6, C1 is minus 7, A2 is 12, B2 is 18, C2 is minus 21. And now we will going for the ratios. A1 by A2 after simplification is giving me the value 1 by 3. B1 by B2 after simplifications 1 by 3. C1 by C2 after simplification ratio is 1 by 3. So if you look at the case, all these three ratios have the same value 1 by 3, 1 by 3 and 1 by 3. So we can say A1 by A2 equal to B1 by B2 equal to C1 by C2. And this is the case of infinite solutions. So we will have infinite solutions. So what we have done, we have first written the coefficients along with the sign here. Then we have checked the ratio of each of the part, that is A1 by A2, B1 by B2, C1 by C2. And then we have found that each of the part have got the same value, that is same ratio. And once the ratio are all equal, it will be coming in the category of infinite solution. Then coming to the last part, the question is check whether the given equation will have no solution. The equation is 3x minus 5y is equal to 7, 6x minus 10y is equal to 3. Again we are going to find out the coefficients. A1 is 3, B1 is minus 5, C1 is minus 7, A2 is 6, B2 is minus 10, C2 is minus 3. Then we will be going for the ratio of A1 by A2, which is coming to be 1 by 2 after simplification. B1 by B2 again after simplification is coming as 1 by 2, and C1 by C2 after simplification is coming as 7 by 3. So if you look at the condition here, the A1 by A2 is equal to B1 by B2 but not equal to C1 by C2. This is the condition here. And once this condition is given, that means these two pair of equations will have no solutions. So it will have no solution. So again, if we look at the process of the third pattern, we have first written the coefficients along with the symbol. We have found the ratios of all the three parts separately. Then we have found that the first two parts have equal values, the third one was not equal, and that is the criteria of no solutions. So this pair of equation will have inconsistent solutions. That means no solutions. So in our linear equations, we will having altogether three cases. In the first case, where A1 by A2 was not equal to B1 by B2, it was the case of unique solution. You can solve this two pair of equation by any method, either by substitution, elimination, or cross multiplications to get the value of x and y. And in this case, since all the ratios were equal, we will have infinite solutions. If you remember the case of graph, there will be overlapping lines. In the first case, it will be intersecting line at a particular point. And if we come to the last part, that is when the first two ratios are equal and the third one is not equal, it is the case when we have no solutions. And it was the case when we are going to get in graph two parallel lines which are not intersecting. So if you are going through the cases here, this is the way we can get the solution, and this is the technique of solvability of linear equation. So you have to keep in your mind, whenever we get a linear equation, we have to first check the conditions. If the first two conditions are coming, then they will come in the condition of consistent, otherwise inconsistent. In the first case, I will have a solution, unique solution. In the second case, I will have infinite solutions. So I hope you have understood the questions. In the next class, I will be taking up some more topic of this chapter. So thank you and have a nice day.